Dear students, so in this class, now let us discuss about semi-linear equations and quasi-linear equations. So what is a semi-linear equation? Semi-linear equation means the equation is of the form pxy zx plus qxy zy equals rxyz. So this equation is said to be a semi-linear equation. Pxy zx plus qxy zy equals rxyz. So now let us consider the one parameter family of the curves in xy plane. The one parameter family of the curves in xy plane defined by the ordinary differential equation. Suppose as dx by dt. Let us consider the one parameter family of curves in xy plane by using this differential equation or ordinary differential equation dx by dt. Dx by dt equals pxy and dy by dt. dy by dt equals qxy. So, by using these two arguments, what about the dy by dx here? Dy by dx is qxy by pxy. Okay. Yes, dy by dx is qxy by pxy. So, this curve has a property that along zxy will satisfy the ordinary equation, then dz by dt equals rxyz. Consider the semi-linear equation pxy zx plus qxy zy equals rxyz. Then consider the one parameter family in xy plane. So having the partial differential equation dx by dt is pxy and dy by dt is qxy such that dy by dx is qxy by pxy. Also it satisfies dz by dt is rxyz. Okay. Now let x0 y0 be any point in xy plane. X0 y0 be any point in xy plane. So, by the existence and uniqueness of the solutions of initial value problem, an initial value problem has a solution, the solution is exist and the solution is unique. So the uniqueness and existence of the solutions of an initial value problem for the ordinary differential equation dx by dt is pxy and dy by dt is qxy will define a unique characteristic curve xt equals x x0 y0 t. Similarly yt equals y x0 y0 t. Okay, then such that what is x0? That is means x0 equals x0 and y0 equals y0. Then therefore there exists a unique solution for this equation has z equals z0 x0 y0 t or z equals z of x0 y0. So x0 y0 be any point in that xy plane. Then the existence and uniqueness solutions of the initial value problem, then it defines xt equals x0 y0 t and y equals y x0 y0 t, which satisfies this ordinary differential equation dx by dt is pxy and dy by dt is qxy. Therefore, by using these initial arguments, xt equals x x0 y0 t, yt equals y x0 y0 t, with x0 equals x0, x0 equals x0 and y0 equals y0 have a solution z equals such x0 y0 t. So this is the method to find out the solution of a semi-linear equation whose solution is in terms of such by using or by solving this ordinary differential equation dx by dt is pxy and dy by dt is qxy. Moreover, dz by dt is rxyz. So we have to solve the semi-linear equation, we have to find out the solution which satisfies z equals z x naught y naught t by solving this or with the help of this ordinary differential equation. Dx by dt is pxy, dy by dt is qxy, as well as dz by dt is rxyz. This dz by dt is rxyz, that is in terms dz by dx. Actually, what is dz by dx? Here dz by dx is, that is zx plus zy into dy by dx. On solving this one, dz by dx, that is zx plus, yes, it is zy into dy by dx. So it is pxy zx plus qxy zy all divided by pxy, that is rxy by pxy. So from there we have dz by dt is rxyz. Okay. So how to solve a semi-linear equation? So to solve a semi-linear equation means we have to find the solution z equals zx naught to y naught t satisfies these initial conditions by solving these ordinary differential equations. Dx by dt is pxy, dy by dt is qxy, as well as dz by dt is rxyz. Okay. So now let us see how to solve a semi-linear equation. So solve x zy minus, consider semi-linear equation, x zy, that is pxyz. Okay, p z xyz. Here x zy minus y zx minus y zx equals z. With the initial conditions, zx not equals f of x, zx0 equals f of x, where x greater than or equals 0. Solve the semi-linear equation. How to solve the semi-linear equation? We see that to solve the semi-linear equation means we have to find a solution that is z equals zx naught to y naught t, which satisfies the equations, partial order ordinary differential equations, dy by dt equals so, and dx by dt equals so, and dz by dt equals and so on. Okay. So in order to solve this semi-linear equation, first compare it with the standard semi-linear equation. So how to solve this one? The standard semi-linear equation is p xy zx plus q xy zy equals r xyz. Okay. So on comparing, what is p here? With p is nothing but as what is p and q. So here p equals or pxy. Pxy equals minus y, comma qxy. What is qxy? Qxy equals x and rxyz. Rxyz equals z itself. On comparing with the standard equation, standard semi-linear equation. Okay. So what about dy by dx? We know that dy by dt is qxy and dx by dt is pxy. So what is dy by dx? Dy by dx is, yes, it is dy by dt divided by dx by dt. Okay. We know that what is dy by dt? It is qxy, and what is dx by dt? It is pxy. So it is qxy by pxy. That means dy by dx equals qxy. What is qxy? X. Pxy minus. So it is minus x by 5. Okay. So that means it is x dx plus y dy equals 0. Y dy plus x dx equals 0 means x dx plus y dy equals 0. On integration, we have x square plus y square equals some c. Okay. Or for the more convenience, it is x square plus y square equals some c square. C or c square, whatever name. That's only for the sake of solution. So on solving this one, on integration, we have x square plus y square equals c square. Okay. Also, what is dz by dx? Along the curve z, so along the curve z satisfies the ordinary equation dz by dx. What is dz by dx? Dz by dx is r xyz divided by pxy. Okay, why? Because dz by dt. What is dz by dt? Rxyz. What is dx by dt? Pxy. So dz by dx is dz by dt by dx by dt with the same argument. So dz by dx is dz by dt divided by dx by dt. What is dz by dt? It is Rxyz. And what is dx by dt? It is pxy. So here it is z by minus s. Pxy is minus y. So it is z by minus y. Okay, that means dz by dx. Dz by dx equals minus z by. What is y? From here, y square equals c square minus x square. Okay, so what is y here? Y equals square root of c square minus x square. From here, y equals square root of c square minus x square. Agreed. So dz by dx is minus z by square root of c square by c square minus x square. That means dz by z equals minus 1 by square root of c square minus x square into dx. That is a variable separable form. On integration, we have log z equals, what is the derivative of integral of 1 by square root of c square minus x square? It is sine inverse of x by c. So that's a negative sign. So minus sine inverse of x by c plus a constant. Suppose it is k of c. Agreed. So log z equals sine inverse of x by c plus k of c. So what is z here? That means taking anti-log on both sides. So z equals e power minus of k of c. Sorry, as it is some k of c into e power minus sine inverse of x by c. Either it is log k of c, whatever may be. Okay, it's a constant. Or e power k of c. E power k of c is again a constant, which is treated as another constant k of c, capital K of c itself. Okay, so for more convenience, it is taken as k1c. So it is z equals e power sine inverse x by c into k1c, means e power k1c. E power k1c is nothing but a constant. It is treated as some k of c. Take it as k of c. So finally, z equals k of c into e power sine inverse of x by c. Okay. Now, so but what is c? C square is x square plus y square. C is an arbitrary form. So this k of c is an arbitrary function. So what is said? So for more convenience or more specifying, z equals k of, what is c? C means square root of x square plus y square for applying the initial condition into e power minus sine inverse of x by c, x by square root of x square minus x square plus y square. Agreed. Now using the initial condition, which is the initial condition? Zx not equals f of x. Zx not equals f of x means when y equals 0, z equals f of x. Okay, zx not equals f of x means this implies when y equals 0, zxy with y equals 0, what is zx? Zx equals f of x means z equals f of x. Agreed. So that means by using the initial condition, we have f of x equals, z means f of x, y equals 0, k into root x square plus 0, k root x square means kx into e power minus sine inverse of x by x1, sine inverse 1. Agreed. So that means f of x equals kx into e power sine inverse 1 is pi by 2, so it is e power minus pi by 2. Not certain, it is e power minus pi by 2. Okay, so f of x equals kx into e power minus pi by 2. That means what is kx? Kx equals f of x into e power pi by 2. Agreed. Kx equals f of x into e power pi by 2. It is k of c, so it is k of this one. Sorry, not a k into x, it is k of x. So k of x equals f of x into e power pi by 2. So what is k of c? That means k of c equals f of c into e power pi by 2. K of c is an arbitrary function, that is, it depends upon c only. Agreed. So k of c equals f of c into e power pi by 2. Therefore, our required solution z equals k of c means f of c into e power minus pi by 2 into e power minus sine inverse of x by c. So that is our required solution. Z equals k of c. K of c means, so the required solution is, hence our solution is z equals k of c. What is k of c? Which is f of c into e power pi by 2 into e power minus sine inverse of x by c. What is c? Square root of x square minus, x square plus y square. So this is the required solution. Instead of c, again we have z equals f of c. What is c? Square root of x square plus y square into e power pi by 2 into e power minus sine inverse of x by square root of x square plus y square. We have required solution. So this is the method to find out the solution of a semi-linear equation. How to solve a semi-linear equation? First, compare it with the semi-linear equation, then find out the p, q, and solve the ordinary differential equation. That is, dy by dx is, what is dy by dx? It is qxy by pxy, and dz by dx is rxyz by pxy. On solving, then using the initial conditions, here k of c is a arbitrary function, depends only on c. After using the initial condition, we have k of c equals f of c into e power pi by 2. Then supply here, z is this one. Okay, so this is the method to find out the solution of a semi-linear equation. This is the process. Okay. Now we can consider another one. Solve zx plus zy equals z square. Solve zx plus zy equals z square. With the initial conditions, zx not equals f of x. Zx is 0. Zx not equals f of x. There this f of x greater than or equals 0. Here also when y equals 0, z is f of x. Okay, how to solve this one? You can compare. Compare with the standard equations. That is p xy zx plus q xy zy equals r x y z. Okay. So what is zx here? Sorry, p here, and p equals 1, q equals 1, and r x y z, or r equals z square. One compare. Okay. So what is dy by dx? Dy by dx is qxy by pxy. What is qxy? 1. And what is qxy? There is also 1. So means dy by dx equals 1. So dy by dx equals 1 means dy equals dx. Okay. So on solving, what do you get? This solving x equals y plus c, or y equals x plus c, whatever may be. Agree. So on solving, we have x equals y plus c. Now, again, what is dz by dx? Dz by dx is rxyz by pxy. What is rxyz? Z square by 1. So that means dz by z square equals dx. Okay. Again, variable separable form. So on integration, that is minus 1 by z equals x plus. Minus 1 by z equals x plus c. Okay. So instead of c here, we use an arbitrary function, let it be k of c. So here minus 1 by z equals x plus k of c. So that means it is minus 1 by z equals x plus k of, what is c? From here it is immediate, it is x minus y. Minus 1 by z equals x plus k of x minus y. By using the initial argument, we have z equals f of x when if y equals 0. Z equals f of x when y equals 0. Okay, so what do you get when z equals by using initial conditions? When y equals 0, z equals f of x. So it is minus, this becomes minus 1 by f of x equals x plus k into or k of x. When z equals y equals 0, that. Okay. So from here what is k of x? Means k of x equals minus 1 by f of x minus 1 by f of x minus x. So k of x is this one. So what is k of c? K of c equals minus 1 by f of c minus c. Okay, minus 1 by c minus 1 by f of c minus c. That equals minus sk of c equals minus 1 minus c into f of c all divided by f of c. Then on solving here, that is k of c. K of c equals minus 1 minus f of c into c divided by f of c. Okay, so it is minus 1 minus what is c? C equals x minus y. So that is minus 1 minus f of x minus y into x minus y by f of x minus y. Then you can substitute all of these values in here. So finally we have 1 by z equals f of x minus y by 1 minus y into x minus y after reducing this one. Okay, so this is the method to find out the solution of a semi-linear equations. Clear? Means to find out the solution of a semi-linear equation, you have to solve it in terms of z by solving the ordinary differential equations dx by dt, dy by dt and dz by dt. Moreover, it is dy by dx is qxy by pxy and dz by dt is dz by dx is rxy z by pxy. Okay, thank you.